Hello everyone, in this video I will introduce the performance of integrating Q-learning into a simple game. The game used here is a Pygame game I developed called Matchstick Man, and later I will explain the detailed code. First, let me explain what Q-learning is. Q-learning is reinforcement learning algorithm that know how to take action in an environment to maximize some communicative reward through trial and error. Simple put, it's like teaching a child to play a game. Through continuous attempts and mistakes. The child gradually learns which behavior leads to better outcome. Context of the Matchstick Man game, the state can be composed of the following factors: the vertical position of the Matchstick Man on the ground or in the air, the jumping state of the Matchstick Man on the ground, rising or falling, the horizontal distance of the nearest obstacle, close, medium, or far, the vertical distance of the nearest obstacle, above the Matchstick Man or below the Matchstick Man. These states are described and represented by a unique index. For example, state 1, state 2, and state 3. In the Matchstick Man game, the action can be move left or move right, jump or do nothing. Suppose we have 3 states and 4 actions. The Q table might look like this one. At the beginning of the training, all values in the Q table are 0 because the Matchstick Man has no experience yet. After several training sessions, the Q table might look like this. In state 1, moving right has highest Q value, 5.0. indicating that moving right is the optimal action in this state. In state 2, jumping has the highest Q value, 7.0, indicating that jumping is the optimal action in this state. In state 3, do nothing has the highest Q value, 6.0. indicating that do nothing is the optimal action in this state. Through this process, Q-learning gradually learns how to achieve high scores. So, how is implemented in this game? Here is the source code. The comments in the code are written in Chinese, so if you have any questions, you can translate them directly. In the code, the design of Q-learning mainly focuses on following parts. The first one is initialization of the Q table. Here, the Q table is a 2-dimensional array used to store the expected cumulative reward for each action in each state. In the code, the Q table is initialized as a 0 max thread. The second here. Second is definition of state. The state is composed of the vertical position of the Matchstick Man, the jumping state, the horizontal and the vertical distance to the obstacle. This information is described and used to index the Q table. The third here. The third is action selection. The epsilon gradient strategy is used to select actions with probability epsilon. A random action is chosen. Otherwise, the action with the highest reward in the current state from the Q table is chosen. The fourth is definition of rewards. Different rewards are given based on the Matchstick Man behavior. For example, successfully avoiding an obstacle results in a positive reward, while colliding with the obstacle results in a negative reward. The fifth, updating the Q table. The Q table is updated using a Q-learning update formula, as shown in the top right of the video. In the code, the part that updated the Q table is here. The sixth is decay of exploration rate. As the training progresses, the exploration rate epsilon gradually decay to reduce random exploration and rely more on learned knowledge. The last one here. The last one is training loop. In the game's training loop, the state is continuously updated. Actions are selected and executed. Rewards are obtained, and the Q table is updated. Through these parts of the code, the Q-learning algorithm is implemented in the Matchstick Man game, allowing the Matchstick Man to optimize its behavior strategy by continuously learning and updating the Q table. Now, let me show you how to run this game. First, log into your GitHub. Then, search for Siri Baby. Siribabe. Oh, here it is. And click users. Okay, here. Click on Run Matchstick Man. And click code and copy this one. And follow the steps in the first link at the top right of the video to get my files. Now I have the files downloaded and extracted. Go into the folders, open the Mary file using PyCharm or other computers. Oh, I opened it already. Okay, it's here. I have set it to run 1000 times, but you can modify the number of the runs according to your needs. Here. Okay. Let's run it. And you can see the Matchstick Man game running. We just need to waiting. Yes. We just need to wait.
2,000 years later.
Okay, now we can see that the game has finished running and the 4 graphs have appeared.
Nice.
The first graph is average reward per episode, which shows the change in game score over 1000 rounds.
You can see that the area under the blue line is getting larger, although not by much, which indicates that Q-learning has had some impact on the score over 1,000 learning sessions. The second graph is average Q value per episode, where the curve rises quickly before 400 episodes and then rises slowly from 400 to 1,000 episodes, with fluctuation throughout the progress. This indicates that Q-learning learned rapidly in the early stage and then stabilizes, but still adjusts its strategy to optimize results. The third graph is exploration rate, where the rate drops quickly in the first half and then slowly decreases, gradually approaching zero. This indicates that as learning progresses, the algorithm reduces random exploration and relies more on learned knowledge. The fourth graph is success count, where success is defined as achieving a score greater than 1,000. We can see how the success count changes as the number of game sessions increases. Okay, that's it for our learning about Q-learning today. Do you understand Q-learning a bit better now? Finally, don't forget to like and follow to see more of my hardworking learning life. Thank you.